Hey everybody, this is Mike. Welcome back to the shop for another Saturday shop projects. I believe this is number 8. So we've got some projects I want to get knocked out today. I've got my 06 2500 Duramax on the rack, and it's time for a lube oil filter service. So I'm going to rotate tires, drain the engine oil, fuel filter, engine oil filter, and then I also bought some steel braided brake lines for it a few months back. The truck's 14 years old now, and I kind of wanted to get those original rubber brake lines off of there and upgrade while I'm at it. Plus it's time for a brake bleed. I usually bleed the brakes every few years and change the brake fluid in it. It's time for that. It's been more time than miles. I think it's only been about 18,000 miles, but it's been about 3 years. So we live in a fairly dry climate here in northern Utah, so we don't have a lot of humidity and everything, but still I want to get that fluid out of there. I usually do it every 2 to 3 years on all my vehicles. This one's gone a little bit long, so it's time to do it. I did think I did it right before we moved and built the new shop, so it's time to do it again, and at that time I'm going to go ahead and put the brake lines on. So also, I have my DiAcro 24-inch finger brake set up finally. I built a stand and everything for it, got it set up over here, and I noticed a couple of the adjustment screws were bent and a couple of the pins are missing somewhere, so I'm going to machine two new adjustment screws and 2 pins and knurl those. Let's see. Oh, and then I've got a Hayman project. I have a buddy of mine used to do a lot of power sports work, so ATVs, sand rails, motorcycles, snowmobiles. I don't work on snowmobiles or ATVs anymore. Road bikes, yes. Dirt bikes, not so much. But there, for the 20 years I had my business, we worked on a lot of them. So that was one of our main focuses. So anyway, a friend of mine who I used to build a lot of his snowmobiles and ATVs for the sand for hit me up the other day. His YFZ 450, he went to ride it and it's not running, so he went ahead and pulled the carburetor off, dropped it off to me last night. So I told him I'd go through it and clean it all up for him. It's probably plugged up. It smells pretty bad. So I've got that Hayman project to do, and then I think that's probably much it. That'll keep me pretty busy today. So let's go ahead and get started. Before I move forward, I want to thank everybody. I got a lot of new subscribers over the last few weeks, month. I've had a couple hundred, I think. So I appreciate that. I hope you're not disappointed in the content. And if you're new to the channel, or this is your first video, and you're a total gearhead, go ahead and click on that subscribe button, because you're going to, you won't be disappointed with the content, I hope. So anyway, let's go ahead and get started. So my son come by to change oil sand unit on his truck, and he brought his Jeep by. So I figured I'd do a quick walk around of it real quick. There's the modular front bumper that we built, I don't know, 6 months or so ago. So it's got each wing on it, center section, and an underbelly skid, and has worn 10S, Xeon 10S, and then some KC 4-inch LED lights on it. And Dana 44 front and rear axles with 456 gears, 33 BFG KO2s. And we built the sliders on it as well. There's kind of a side profile of it. And the rear bumper and tire carrier we also built. Had to put the mud flaps on because of Utah regulations. He and I both got popped for mud flaps shortly after we got them done, shortly after I went to my 37s, so had to put those stupid looking mud flaps on it. But all in all, it's a pretty clean Jeep. We got a little speck of rust to fix right back there behind the rear door. Other than that, everything's done on it, and it runs good, rides nice. So here's the brake line kit I ended up going with. This one is a Russell. It's a a friend of mine had used this and recommended it, so I went with this one. It looks pretty decent. I mean, the crimps on it are really well done. The hose, the steel braided line, looks very nice. The banjo fittings, everything's very well. I like the fact they used, one of the things that sold me on it was they used a nut to secure the bulkhead side rather than the OEM spring clip style. So I really liked that on the front. Again, they look well made. It was a fairly inexpensive kit, so that's another reason why I went with it. But it's good quality. I'm not familiar. I don't endorse this at all. They're not endorsing me, rather. It's just the one I bought for this application. It comes with a center rear and then each left and right and then 2 fronts. So it's a 5-piece kit. Now I will admit, the one thing that I'm not a fan of, and it's just personal preference, is these aluminum banjo, these aluminum crush washers they sent for the banjo bolts. I'm not a big fan of the aluminum ones. I generally buy these copper ones bulk, and I usually buy them a package. I think they come in a package of 50, and it looks like I'm needing to replace them because I'm getting low. So I dug those out, and those are what I'm going to be using in this application. But other than that, it looks like a pretty decent kit. Now the brake lines that I do have really have experience with are Crown for the Jeeps. I think their quality is very good. That's what I've been using on the Jeeps for the last, probably coming up on 10 years now, nine plus years since I've been building Jeeps. I've been using the Crown brake lines, and they are very good component. They're a very good product. As far as off-road, for the 25 plus years I was building sand rails and quads and so forth, I pretty much used exclusively Cartech. And man, I tell you, after 25 years of using Cartech products, I never had a bad product from them. It doesn't matter whether it's a limiting strap, a brake line, fittings, anything from them. I had really good luck with. So anyway, I'm using the Russell on these. I believe they're owned by Edelbrock now, but don't quote me on that. It's just something I read a while back. So we're going to go over to the truck and remove the OEM passenger front line and install the new steel braid line. Before I get too deep in, a lot of times what I prefer to do is kind of guesstimate how I'm going to run the routing. Now the OEM one comes around here to a steel tab, but with the 6-inch RCD lift I have on my truck, the vertical knuckle is too wide, the girth of it, so the steel bracket wouldn't fit. So I just had it zip tied here in place along with the ABS sensor. I'm going to change that up. I'm actually going to drill and tap into the back side of the vertical here, and probably tap at a 1/4 and put an Adele clamp to hold the new line. But so that's pretty much the direction I'm going to come up. So I'm just going to kind of route it around and kind of get a good feel for how it's going to run. So yeah, there goes to the banjo bolt. Then it'll run up to the back there and an Adele clamp, and then from there I'm going to go into this upper strap clamp. I will peel that off. I'll pull the line off and get this over in the vise and open that up and re-crimp that around the line, and then it'll go right there to the factory bulkhead. So that's the way I'm going to run it. And oops, got a little bit of grease from the upper ball joint on the new line. Can't have that. So let's wipe that off. So first, what I'm going to do is let's cut this zip tie out of the way that holds the OEM brake line and the ABS sensor. And then I'm going to measure kind of where I want to put that Adele clamp. Which is about right there. So then I'm going to, like I said, I'm going to test again. Make sure that the Adele clamp is where I want it. Better to measure twice and cut once or drill once, however you want to. Yep, that'll be good. Nice gradual bend. You don't want to kink those brake lines. Center punch, and I've got safety glasses kicking around here somewhere. Okay. Into drilling it with a number 7 drill bit here for a 1/4-20. It's far enough. I'm just using the 1/4-20 1/2 inch. I put the rag here to keep the metal shavings out of the rotor and brake components there. Okay, let's get a little tap block here for 1/4. Kind of hold it up there so it's square going into the hole. Good enough for the on depth. Clean the tap off, clean the tap guide, so they're ready to use next time. Don't put anything away dirty. Okay, so clean that hole out. Awesome. Okay. That's drilled, so now we're going to move on to removing the brake line. So I'm just going to clamp it off here. Just got some hose pliers and don't pinch the ABS wire, but clamp that off. And then remove the 6mm bolt, 10mm head up here that holds this clamp on. And I've got a drip pan down underneath the brake components here, so when I remove this, everything will the plan is everything will drip down onto that drip pan rather than the floor, but you know how that goes. It doesn't always work that way. So that one's loose. Let's go up and break the upper bulkhead line loose now. For that I'm just using a 9/16 tubing wrench. Okay, and then once you get it broke loose, you can just go to a regular combination. It'll be fine. Pull this spring clamp out of the way. Maybe. There we go. Spring clip out of the way. Finish removing the brake line. Let's loosen the bulkhead clamp. Okay, undo the fitting. And of course the crush washer is crushed onto the bolts. It's got to be threaded out through. It's not just going to fall right out. No, I'd make it too easy. Okay. Make sure that's all cleaned off nicely, and the new banjo fittings are ready to, or the crush washers are ready to go in place. There we go. Couldn't get the angle of the dangle quite right. So that's tight. Spray off any residual brake fluid. Get it off of there. You want to get that all off of there for a couple reasons. Number one, you don't want to take the paint off your frame. And number two, when you do start bleeding and putting pressure to it, if you've got brake fluid all over, it's going to be harder to determine whether you have a leak or not. So if you got a nice clean area there, it's a little easier to determine if you have a leak. So go ahead and clamp the Adele clamp in place. I just put a little bit of anti-seize. Here in northern Utah, I use a lot of anti-seize, so you'll see me use anti-seize on a lot of fasteners. And now make sure your banjo fitting is out of the way of everything, clears everything nicely. And you can go ahead and tighten it. Clean the back of the caliper off where you've been losing a little bit of brake fluid. Okay, that looks like that's done. Now the only thing I have left to do is to put the OEM clamp back on, and before I do that, I'm going to tighten up the bulkhead fitting up here. So make sure that's tight to the bulkhead. Okay, that's the clamp I was after, so I just put it in the vise and opened it up. So now I'll go ahead and re-secure this back in the factory location. Anti-seize on the fastener. Now the brake line comes with this little protective sleeve, and I'll tuck that actually up inside of that sleeve, and then take a pair of, I don't know if I can see if that'll show up or not, take a pair of vice grips and see if I can just roll that roll that crimp right back around. Without actually smashing the line. You're just trying to roll it around. You don't want to just smash it. Now I'll just zip tie that ABS line or wire right back to the brake line like I had it before. Use my flush cut diagonals, cut that off, and the front's done, ready to bleed. That'll all show up to the bulkhead, down through the OEM clamp, the ABS wires attached to it, and then back around through an Adele clamp, back down to the caliper. Okay. Go around to the back. Now, I can't remember if I mentioned this or not, but this kit is for a 4 to 6 inch lifted GM truck, and I've got I'm running a 6 inch RCD lift kit on this. So the front lines obviously are going to be longer because the suspension droop. The rear being is how it has the center drop. The center one is the one that's going to be a little bit longer. And actually, when I did the lift, I pulled it loose from the OEM clamp, so it really hasn't even full droop here. with leaf springs and everything, it's not even pulled taut on the line. But anyway, the kit comes with all 5 hoses, so I'm going to go ahead and install it. But the outer axle ones are just the same length as the OEM because there's no suspension change or suspension distance change from where the mounting point of the brake line is here in the back of the axle housing to the brake caliper. So this is pretty much a direct OE replacement here. So pretty simple. Same thing as before, to go ahead and break your caliper loose, let it just kind of drip into the pan. That bottom one usually gets crushed and deformed just enough where you got to thread it out. It doesn't want to just slip through. The top one usually, not so much. The top one will usually pull. Yeah, see, actually the top one right there just fell right off. We'll just let it drop into the pan. All right, had to get a little creative there, and there's the clip. So I had to actually get in there and smash this to get it to relieve some of the tension, and then a good tug and it come right out. So the new kit comes with the proper, I like these much better, these E-clips. So get that line out of the way. There's the old one. Go ahead and put the new one back in place and get started. Get this most of the way in by hand before I have to put a wrench to it. Now you want to make sure you get the banjo fitting lined up before you tighten it too tight, because you can actually swivel it still just a little tiny bit on there before you tighten the fitting all the way, whereas once you get it tightened, it'll automatically kind of clock the banjo fitting. So I like to go ahead and get the banjo bolt installed in position. Okay, line's in place. That line's done. It'll be the same for the other side, front and rear. So I'll go ahead and finish those up, and then we'll move on to the other. This is the center hose, which is pretty straightforward, but I figured I've already shown the other ones. I may as well show this one too. Sorry, I'm trying to dance around here and get my drip pan spread out. I missed it in a couple places, and so I'm just trying to spread that around. So you can see it fastens to a bracket here on the diff cover where the 2 rigid lines come out and go out to each wheel, and then up here to the frame bracket. So I'm going to, before I get started, I'm going to break that line loose up there. Because from the factory, they actually have a the receiver side, the hose side has a boss on it, and then the bracket has a cutout that fits in and holds it. So if you pull this clip off first, the hose will spin around and it'll pop outside that little catch. So break the line loose first, then you can go ahead and fairly easily, well, I shouldn't say fairly easily. Yeah, that one come right off. You saw how easy that one come right off. Generally they all do, but those rear ones wanted to fight me. So I got that broke loose. Yeah, and I just put a 9/16 open end on it, and I'll have to hold it into that little recess to get it the rest of the way out. So now I'm going to take the end loose. I'm going to put an absorbent pad right underneath that and see if it'll catch as much as possible into that before it runs all down my axle. Let's see here. I should mention while I've got it up here in the air, doing this, I've got the bucket underneath the engine, draining the engine oil. So kill two birds with one stone here while I'm working back here. So go ahead and pop these loose. Okay. And again, this line's got a nice big bulkhead nut, so it'll come off of that upper bulkhead and come down here to the T. Six of one, half a dozen of the other here. I think I'm going to break that, get that upper one out of the way first. Let me make sure you can see that up under there. I don't know if you can or not. Yeah, we'll get this upper one out of the way. Unthread these, they're already dripping, might as well get them out of the way and get the block secured in place. So I've got the block down here snugged into place. Let's go back up top here and finish removing the upper fitting. Actually being a little bit of a stinker coming out of there. Spray just a little bit of penetrant on it to see if I can loosen it up around that tube. Yeah, there we go. There we go, that's helping. Make the new one going back in a little easier. It was like, felt like it was tight against the flare nut was tight against that tube. Okay, so now I can, don't forget your bulkhead nut. Go ahead and stick that up in place and start it. If I go around that other way, the way it was originally, let's try that. There we go. Like that routing just a little better. Yeah, I think I kind of like that routing a little better, and I can zip tie the vacuum or the vent line and the brake line together there. Okay, so bulkhead fitting's tight. The line coming in to the new line is tight. I've got a nice gradual curve here, and upon compression, this will move freely and down to the block. Each line here tightened in, so the brake lines are officially installed. We'll go ahead and move on to bleeding them as soon as I get the oil filter on the engine. All right, so let's talk drain plugs and drain plug torque and crush slit washers. I was just getting ready to put this all back together, and it clicked with me when I did the drain plug repair on the motorcycle case, the last video. I think I briefly touched on the fact that those drain plug threads, especially in cast aluminum, are not the strongest, so you want to use a new crush washer each time. The reason being is these are designed to actually crush and take and seal up. Once they're crushed, once, twice, some people reuse these 8-10 times, that compression is lost. It's already compressed. So now all that torque is being pulled on those threads without that cushion of that crush washer. So these are cheap. I generally buy them in a package of 8 or 10. I'll get multiples of them and keep them on hand. I do this, all my vehicles. It's a good practice to get into is replacing these crush washers. These are just a 14 millimeter. This is a Napa number. It's a 704-1355. I'm not sure if I've got the. No, that's the transmission one. Can't remember if I've got. No, that's the Honda for the Weiss Acura. Don't have the actual the GM number. I do have a brand new drain plug that I keep on hand also, because me and my son both drive Duramaxes. But anyway, so you can. I had to grab a caliper and measure those, but there is a difference. This is the used one, and it'll be discarded, and this is the new one. So please replace the crush washers on those. It saves the threads in the oil pans, and it doesn't matter whether it's a stamped steel pan with a threaded insert welded in, a captured nut welded in on the inside, or especially aluminum pan. Those seem to be more critical. I see a lot of them with damaged threads on engines and transmissions nowadays, and I would almost guarantee it's because people over-torque them or do not replace this crush sleeve, or a combination of both. Now, I don't know what it is about the Duramax engine, but it raises so much controversy over the torque spec on the engine oil drain plug. It's kind of funny. You get online and everybody wants to know torque specs for this, torque specs for that. People cite out the torque specs. You've got the caliber of people that I never use a torque wrench and just tighten them up and quarter turn before they snap, or good and tight. You hear them all, but the proper way to install a fastener is to torque them. And granted, I'll admit there's a lot of times where on repeated fasteners I'm comfortable with, and not what I consider a critical fastener, I'll tighten them down. I have after 30 years of wrenching, I still feel like I have a pretty decent feel. It's not going to be exact, obviously, but on critical fasteners, I always grab a torque wrench. Oil pans, drain plugs is one of those that I consider a critical fastener. It's not critical as far as if it falls out, it's going to kill you, but it is critical to the life of that drain plug, or excuse me, that oil pan. So please torque these. But the Duramax, for some ungodly reason, brings up so much controversy, because people will ask, what's the torque spec for a Duramax drain plug? Again, you'll have all over the place. You'll have people say, just tighten it, hang on a 3/8 ratchet. Or then you have those that recite 62 foot-pounds. Then you've got others that jump on, that's too much. Torque it half that. The engineers know what they're doing. Granted, I'm not going to stand here and defend engineers on everything. There are some that I scratch my head, but the fasteners have a torque designed into it. I've been torquing this into the factory specs for its life now. Mine has 102,000. My son's has 200 and almost well over 250,000 miles. 260, probably pushing 260. And the entire time we've had these, we torque them to the specs. We've never had a problem. Thread them in by hand, get them started, and then throw them a torque wrench on them, torque them at 62 foot-pounds, and leave it. Again, use a new washer, because they will leak if not, and you'll try to tighten them up, and pretty soon you're buying a pan because you've over-torqued it. So 62 foot-pounds is a lot of torque on these, but it is the required torque. So I'm not going to get in a pissing contest, because there's enough of that all over the interwebs, but you go on any diesel forum, Duramax forum, any of them, and you're going to get all kinds of answers. But yet when somebody recites the torque right out of the book, right out of the factory service manual, they get criticized for it. So just be warned. This does get torqued to 62 foot-pounds. All right, and show that I'm not just blowing smoke up everybody's ass here. There's the old drain plug, new washer. Thread it in by hand. Once I usually do that, I'll get the drain pan down out of the way enough to where I can wipe the residual and whatever comes out from underneath the washer there. Can wipe off around it. Got a few drips there when it was draining. Grab the torque wrench. .62 foot-pounds. 16 millimeter. And there's 62 foot-pounds. It pulls it in tight. You're not gonna, you don't feel any give like the threads are going. That's the required torque. So hopefully, I still doubt that's gonna put that to bed, but I just wanted to show that that is the correct torque for these, regardless of what all the keyboard geniuses say. That is the required torque right from the GM factory service manual. So now I'm just going to change the oil filter, and we'll go ahead and lower this down, get the brakes bled, and throw the tires and wheels back on. I've got my pneumatic bleeder. So I've got the line hooked up, pulling a vacuum on it. Pulling the air, and there comes the fluid. So I'll let it go for a little bit till I see it clear up. I sucked everything out of the master cylinder over there before starting, and then I'm just going wheel by wheel till I get fresh, clean fluid, keeping an eye on that master cylinder that it doesn't run dry. That actually is cleaning up pretty good right there. I'll let it run for just a couple of seconds longer and use about a quart, maybe a little over a quart. I had half a quart to start with, and I opened a new one, and I've got a little bit left in it, so a little over a quart. Yep, that was really clean right there. So it actually wasn't too awfully bad, but it only had, I don't know, 10,000 miles on it. It was mostly time. It was about 3.5 years. I did it right before we closed up the last shop before I moved. Okay, so new fuel filter. This is a Recor PFF 50216 made by Parker Hannafin. Open everything up here. Put the O-ring for the water sensor and the main O-ring. Pull the O-ring off the sensor. Put the new one on. And I like to put a little bit of Silglide on my O-rings. Keeps them from getting damaged upon assembly. So I'll just take a little bit and smear it around that O-ring. Very little, you don't need much. You just don't want it to grab and tear as you're installing the component. Snug it on. Okay. Now, this is where I'll take a little bit of Silglide and kind of put it into the groove. For the O-ring, put the O-ring in place, and that Silglide helps hold it in. Plus there's a little bit that oozes out, and you just smear it around that O-ring. Boom. Done. Quick and simple. Down and dirty. I'm going to go ahead and I also usually write the date and the miles. I think it was 102, can't remember. 102,028 on the miles. And May 16th. So go ahead and put that on, and then put oil in it, and we're ready to fire it up. Truck's done. Torqued the wheels on. Gone around and backed it back and forth a couple times. Crawled underneath, run my finger around all the fittings, made sure to check for leaks. Didn't see any. Went ahead and just kind of give the engine bay a quick blast of air to blow it all off. And I had some fingerprints and stuff on the shroud here, so I wiped it down with some Powerhouse, cleaned everything up, and she's full of fresh oil and ready to go for several thousand more miles. And I'll next probably move over to the Hayman project and get the carburetor. All right, moving on to the Hayman project of the day. Whew, that's nasty. Pull this carburetor down and clean it, and then figure out which jets are plugged. Whew, that is nasty. There's all kinds of, I don't know if that'll show up or not, there's all kinds of crap down inside that bowl. Ooh, and stuff just hanging off of the main jet. I don't know if that'll show up or not. Pull the float. And even the needle is covered in that crap. Go ahead and pull the main jet out. That's not all the way plugged up, but it's definitely plugged. It should be the emulsion tube and the bottom. Yeah, that's got a bunch of crap in it. Pull the jets out of here. If the main jet was partially plugged, I'm gonna bet that pilot, yeah, that is nasty. That is nasty and plugged solid. This is the bleed. Yep. Yuck. Soak all of those pieces. All right, I think I'm going to soak this, spray this out really good, and then I'll soak the bowl and the body of the carb to, and then jets to let them clean out for a little bit. All right, so All the jets are clean, bowls clean, carbs cleaned. I really ought to break down and get a ultrasonic cleaner one of these days, but I just don't do that many carburetors anymore. Back when I was doing a lot of building small engines and everything for racing between sleds and dunes, that would have been ideal. But anyway, maybe one of these days I'll break down and get one. I just can't justify it right now for the carburetor I do here or there. I know they work good for other things, but oh well. So let's go ahead and put pilot jet. That was really plugged up. That was bad. Okay, emulsion tube. Actually, that. There it is. Okay. Bingo. Slide works good there. Okay, now the float. Around. Float and the needle valve. And the pin, pivot pin for the float. Grab my little hand pump for the needle. I like to see these hold about 6 pounds without dropping off just from the weight of the float. Seems to hold pretty good. And then I like the float to be about level with the, parallel with the body. The surface of the, where the bowl meets the body. Okay, looks to hold good there. Go ahead and put the main jet in. And these don't need to be all that tight. I just use a little Mikuni tool here and just go in finger tight. You don't want them too awfully tight, or when you go to change them up on the hill, they're kind of a pain in the ass to change if they're too tight. Make sure you put the little retainers for your vent lines. Make sure you put those back under the bowl, the heads of the screws for the bowl. Okay. Put the drain plug on for the bowl. Go ahead and put the Cover back on for the slide. Okay, for the most part, carb's done, back together, other than vent lines. Those back on. And I think I'm gonna put this in a different little baggie for him, not give him that smelly, nasty baggie back. All right, that's done, ready to go back to my buddy so we can throw it back on his four-wheeler and hopefully go do some playing. All right, so like I mentioned, my DiAcro, the screws were pretty damaged for the tension. So that one there's got a pretty good bend in it. This one here's bent in two places and the end's all mushroomed out. So I built two new ones. What I ended up doing was just taking a piece of grade 8 all thread 5/16 18, cutting the end down a little bit on the end. I think that's down to around 200 thousandths on the end. And then I machined the thimble with a 5/16 18, threaded it down, left a little bit of a void at the end, and TIG welded it, built it up a little bit, and then chucked it back up in the collet and faced it off and put a chamfer on it. So those are my two screws with the jam nuts. Instead of the regular screw heads, I actually made knurled. And then on the side, for the angle of the finger that comes up, or not the finger, the leaf where it comes up, that pin was broken. You can see it was sheared off, and so it's a 1/4 inch diameter by about 3/4 of an inch long. So I machined one. I got the other one over here I'm doing now. So I machined a new one, knurled it, and machined it down to 250 thousandths. I just need to face the end off and put a chamfer on it, and then I'm going to case harden or temper these rather with just some an oil temper. So I'll get that other one done, and then these I'll probably just blue. I got some cold bluing, and I'll probably just blue the ends of these two knurls, but these here I'm going to oil temper them. So let's go over and finish up this one. This is the last little push pin. So I'll drop my tool down on there. And I've already faced the end of this off, so I want 3/4 of an inch. So I'm just going to come up and touch it. Move my soft stop over here with my indicator on it. Zero it out. I'm going to move over 750 thousandths. $750 thousandths, and then that's where I'm going to zero out my stop. And then I'll turn this down to 250 thousandths. Oops, might help if I put it in the right direction here. I had it on the, I had it going away from the headstock while I was finishing up the knurl. Quarters of an inch. Pretty healthy cut right there. It's about 60 thousandths depth of cut. It's a nice finish though. Let's see where we're sitting at. Under 93 thousandths is what we need. Almost a full revolution. I come up about 1 thou shy so I can bring it up with just a file. Get a nice clean finish. Creep up on it. So we'll see where it lands. One thousandth. So let's come in and touch off here. Slight chamfer on the inside here. Okay. Now we're going to part that off. Okay. Part dropped right off. off my parting tool, put that away. All right, so I just went through and put a little bit of cold bluing on them, on the parts. I think they turned out pretty good. There's the two little push pins with the knurls that hold the, keep the leaf, set the angle for the leaf. And then there's the fine adjustment with the jam screws. These ones here didn't blue quite as much because this was some hardened steel that I didn't realize until after I'd already started knurling it. And then when I started going, I thought, well, I'll just keep going. It didn't knurl too bad, not near as good as the knurls on these pieces, but pretty decent, so I just kept going with them. So, but the bluing didn't take too much because they're so much harder of a metal. So let's go over to the pan brake and throw these in real quick. And here's, just for some comparisons, there's the old screws, and there's what's left of the one pin that was damaged. So, okay, let's go over to the brake and put these together. There's the little push pin that goes in so that it stops at a certain degree. There's 90, so it'll stop when it gets up to 90, and then this is the fine adjustment. And there's one for the other side. There'll be a second one up. And that one's damaged. That one's gotta clean those couple of holes up over there. Yeah, you gotta clean that up just a little tiny bit. There's the fine adjustment. Knurl actually feels pretty decent in there. All right, so now that stops it right when it gets up to 90 degrees. That looks good.